All right, let's talk about making sense of data. And when we talk about data, we're talking about things like variables and graphing. And part of the reason we graph things is to show patterns and trends as it shows here. So let's talk about how we make sense of our data. Now, when we talk about data, we need to talk about two different aspects of data. There are two types of variables, dependent and independent variables. So let's talk first about dependent variables. Dependent variables in an experiment are the things that you actually measure. So the dependent variable, think of it this way, is the measured variable. Now, because it's the measured variable, we don't know in advance how it's going to change until we actually do the experiment. So when you think about what the variables are in an experiment, try and decide whether or not it's something that you were looking for or whether it's something you already knew. If you didn't know what it was going to be and you had to measure it or count it or something like that, then it's likely the dependent variable. Now, when we graph variables, or when we plot out our graph, the dependent variable goes on the vertical axis, or what we call the y-axis. Okay? There's also the independent variable. The independent variable is the one that you change or manipulate. All right, so the dependent variable is the one that you measure. The independent variable is the one that you change. Okay, and this is predictable. And it's predictable because it can only change because we choose how it's going to change. And you plot on a graph the independent variable on the x-axis. Okay? Now, once we've plotted our graph on the x and the y-axis, we put the dependent variable here and the independent variable along the x-axis here. We can give our graph a title. And usually the convention that we follow, or the kind of the formula that we follow for naming our graph, is this. We call it the effect of whatever the independent variable is on the dependent variable. All right, so let's take a look at some of this stuff in some examples. Here's experiment number 1. Let's say we're trying to answer the question, how does fertilizer affect the growth rate of plants? If we put fertilizer on it, we want to know how it changes, how quickly, that's the rate of the growth of plants. All right, so we set up an experiment and we're testing different amounts of fertilizer on different plants. So each different specimen is going to have a certain amount of fertilizer, and some are going to have more and some are going to have less. And we're going to measure the growth, and we'll measure the growth by measuring the height of the plant. Okay, so which of these is the dependent variable? In other words, which one are we going to plot on the graph on the y-axis? Well, obviously, the one that we're measuring that we don't know beforehand is the height of the plants. So the height of plants is going to be the dependent variable. The independent variable is the one that we can change, and we know how much it's going to be because we're actually changing it. And that, in this case, which we're going to plot on the x-axis, is going to be the amount of fertilizer. So when we plot our graph, we're going to put the height of plants along the x-axis, the y-axis, and then the amount of fertilizer along the y-axis. The x-axis. So across this way is where we're going to put the amount of fertilizer. And we're going to title our graph, the effect of the amount of fertilizer, that's the independent variable, on the dependent variable, which is the height of plants. So that's an example of how we can identify the dependent and the independent variable in an experiment. Remember, the dependent variable is the one that we're measuring. The independent variable is the one that we are manipulating, or the one that we're changing. Okay? Let's take a look at another example. Let's say we ask the question, how does exercise affect the heart rate of 9th grade students? So before we get to this, try and think about what it is that we know beforehand, what we can change, and what we're going to be measuring. All right, so we set up an experiment. We're testing, let's say we test different lengths of time of exercise on the heart rate of students, and we measure the time that we're going to be exercising, or that students are going to be exercising in minutes. Now, the way I worded it is a little bit tricky because we're going to measure the amount of time that they exercise, but actually that's what we can control. We can say, you exercise for 1 minute, you exercise for 2 minutes, and you exercise for 3 minutes. Okay, so what in this experiment would be the dependent variable? In other words, what is going to go on the y-axis? And I'll try and do it right this time. The y-axis is going to be the up and down axis. Okay, that's the dependent variable. That's what we're measuring. If you think about it, it's going to be the heart rate. We're measuring how many beats per second, probably, or per minute rather, each student's heart is going to be beating. We don't know that before the experiment starts. We're going to be measuring that. That's what we want to find out. Now, the independent variable is the one that we control. And again, the independent variable is what goes along the x-axis, all right, the horizontal axis. All right, so if you think about that, what do we know? What can we control? And it goes back to that little way that I worded it before. We know and we can control the minutes of exercise that each student is going to go through. All right, that we can control. We're not, even though we're going to measure the amount of minutes, that's something that we are controlling because, again, we're saying you're going to exercise for this long, and you're going to exercise for this long, and you're going to exercise for this long. So when we title our graph, we're going to title it this way: the effect of exercise on heart rate. All right, notice again, it's the effect of the independent variable on the dependent variable, or what we're measuring. Here's another example. Let's say we're trying to answer the question, what is the favorite drink of students? And so we set up a survey to ask students what their favorite drink was. All right, so think about that for just a second. What would be the dependent variable and what's the independent variable? Remember, the dependent variable is what we're trying to measure. Okay, so that's going to go on the y-axis, the up and down axis. That is going to be the number of students because we're going to measure it this way. We're going to set up different drinks, and we're going to try and figure out how many of each student likes a particular drink. So the independent variable, think about what we know, what we're going to set up, the way I just described it. We're going to set up different drinks, and we're going to try and figure out how many students like each one. Well, obviously, we're measuring the number of students, so what we can control is the type of drink. So we can set out certain drinks on a table and decide and help students decide which one they like the best. Okay? Now, in order to represent our data, we make pictures of our data. Right? So we draw graphs. And there are a couple types of graphs that we're going to use in science almost on a regular basis. One of them is a line graph. Now, we use line graphs for specific purposes. And whenever we want to show continuous change, or how things are changing over time, we use a line graph. Okay? Now, there's also a type of graph called a bar graph. And sometimes we'll see types of bar graphs that we call histograms, and we'll deal with those later on. When we we use a bar graph to graph data that is in disconnected groups. In other words, we're not looking at how things change over time, but we're looking at separate individual groups and the effects on those individual groups. Okay? So, if we're looking at data, and we're looking at data over time that's showing continuous change, we make a line graph. All right. If we're looking at data that is in disconnected groups, we may have similar plots on our graph or similar points, but we're going to represent it in a slightly different way. We're going to represent it as bars. So the big question is, how do you choose which one you're going to use? And obviously, you have to decide if it's continuous or if you have groups or things that are disconnected or individual. So let's look at an example here. Let's say we're looking at how elevation affects temperature. And we have our data here, and we want to show a picture of that data by graphing it. So you see, again, we've got temperature, which is the dependent variable. Okay, we had to measure that. And elevation along the x-axis is the independent variable. We knew how far we were going down. We could control that. All right. And so if we were to plot that data on this graph, it would look something like this. So the question is, are we going to use a bar graph or are we going to use a line graph? Well, we're going to use a line graph, and here's why. Because as we look down this elevation, we're looking at a continuous series of numbers. So we can see that there's continuous change over time in this data. All right, so we're going to create a line graph. And the nice thing about a line graph is you can actually predict data points that you don't actually have data for. For instance, we could find out what the temperature would be at 1,200 feet above sea level. All right, all we have to do is find 1,200 along the bottom axis here. All right, and we have to follow it up to the line. And if we read it across this way, we find that the temperature would be about 18 degrees. So even though we don't know what the data would be, we didn't take data at that particular point, we can still find it out using a line graph. Here's another example. Let's think back to that experiment that we talked about before. Which drink do you like best? So here's our data. We have 5 different types of drinks, and we have the number of students that like each one. All right, so if we plot out the points, again, we've got the number of students here. That's our dependent variable, and our independent variable, the type of drink, is down along the bottom. So we'll plot out the points. Okay, now, again, do we use a line graph? Okay, if that's the case, where would we find Red Bull? Well, we could do that with a line graph, but here, that doesn't really make sense. So it doesn't make sense to use a line graph here because this is not a continuous set of data. All right, so we couldn't decide, I mean, does Red Bull go there? Does Red Bull go there? We can't use it that way, right? So obviously, a line graph is not the appropriate graph. In this case, the most appropriate type of graph is a bar graph. Okay, so we can plot out and we can draw bars to show the different amounts of people that like each one of these drinks. And just by glancing at this graph, we notice that water and tea are the most popular drinks. And coming in a close, I guess these are tied for first and second here. This would be third place. That would be Gatorade.